A hyperbola has the equation x squared minus 9y squared equals 9. Find the vertices, foci, and asymptotes. We know this will be a hyperbola because the x squared and y squared terms have opposite signs. But to get it in the standard form of a hyperbola, we want the constant term to be equal to 1. To get it in this form, we need to divide both sides by 9. When we do that, we're left with x squared over 9 minus y squared over 1, because the 9's cancel, equals 1. You don't actually have to write y squared over 1. You can just write y squared, but I'm going to write it like this because it'll be a little bit more clear when we're looking for the vertices, the foci, and the asymptotes. So because the x squared term is the one that's positive, we know that this is going to be a hyperbola that opens horizontally. And we have information on where the vertices, the foci, and the asymptotes should come from. The vertices for a hyperbola like this are at the points plus or minus a, comma, 0. In this case, because a squared is 9, that means a is 3, and so the vertices are going to be at plus or minus 3, comma, 0. Now, for the foci, we know that these are going to be at plus or minus c, comma, 0, with the relationship that c squared equals a squared plus b squared. Now in this problem, a squared is 9 and b squared is 1, so this is going to be 9 plus 1, which gives us 10. So because c squared is 10, we know that c will be the square root of 10, and that means that the foci are at plus or minus root 10, comma, 0. Finally, for the asymptotes, we know that these are going to be the lines y equals plus or minus b over a times x. Now here we know b squared is 1, which means that b is 1, and a squared is 9, which means a is 3. And so the asymptotes are going to be at plus or minus 1 over 3 times x. So here we have our vertices, our foci, and asymptotes. And this is our answer.